All right, hi everyone. My name is Blake, and yeah, I'm here to talk to you today about OpenTelemetry. So I suppose first off, has anyone used OpenTelemetry, distributed tracing, that sort of stuff? We've got any expertise? A little bit. Okay, cool. So a bit about me. I'm a site reliability engineer at Codat, and as with absolutely everybody, we are also hiring. So yeah, senior devs, everything. Also SREs. So if you fancy moving over to the dark side, and coming to work with me in site reliability engineering, this sort of stuff, networking, making systems more scalable, performant, that sort of stuff. Yeah, chat to me afterwards. So why am I giving a talk today about OpenTelemetry? Well, I've spent the last few years focusing a lot, like way too much time, on observability systems. Quite a few major observability projects like, hey, we're going to revamp absolutely everything, we're going to put something brand new in place. Experience with Datadog and Elasticstack, and that's pretty much just implementing them both from scratch. And yeah, recently finished at Codat implementing a distributed tracing with OpenTelemetry and Codat. Still not an expert here. By all means, OpenTelemetry is very new, and it also moves very fast. You'll see in a minute, we've got like release candidate versions of NuGet packages. I promise you it's stable now. Cool. So what's observability like today? Why the hell do we need tracing? We've already got logging, right? Well, everybody has logging, and I don't know about you, but when I try and debug a system with logging, it's still not a walk in the park, right? It's very reactive, what went wrong. If I don't have a log for the thing that went wrong, I'm screwed. Like performance issues, good luck debugging performance with logs. That's never a fun experience. And honestly, they're pretty useless for things like overall system health, right? And that's where you usually end up looking at infrastructure monitoring. So that's not just your CPU utilization, your memory, that sort of stuff, but also, what's your application actually doing? Sticking some metrics around that sort of thing, adding queue monitoring, health checks, all of that. And that's what I mean by infrastructure monitoring. So that's great. There's still gaps. Logs really don't give you the whole story. And if you've got performance issues with your application, even if you've got both logs and metrics, unless you've got metrics in exactly the place that is causing the performance issue, again, good luck. Usually a process of elimination at that point, and you've got to go in and add more metrics and figure out what the hell's causing the problem. And metrics, as I say, usually high level, usually predetermined, so you can't really go in and say, if you've just added a call, unless you've got measurement on that and some instrumentation, you don't know how it's performing. And all in all, you still don't know what your services are actually doing. Like the first time we switched on distributed tracing for an application, there was definitely a point where we had a trace that just went like that, and it was as long as your arm. And yeah, there's some wonderful insight to be found by enabling this sort of stuff. So what is it? What is distributed tracing? Basically, it tells you everything, at least for the high level, like I'm going to call out to a service, I'm going to call out to a database, I'm going to call Redis, that sort of stuff. Everything within a distributed transaction across the entire distributed system. And from that, you can get really low-level metrics as well. So it's not just the trace, there are some value-add components with metrics, and we'll see that in a second. So this is a trace. This is a real trace. This is from one of our production systems. You can see at the top, it says public API, so that's the name of the service, and this is getting some build data, by the looks of it, for a particular company. We work in fintech. And cool. So to start with, you've got a span right at the top that says, hey, this is like the entire transaction. This is what I was trying to do. So I was trying to execute this API endpoint. And underneath it, these are all of the different things that are happening as part of that. So you can see we've got in the green blocks, we've got a HTTP request. Underneath that, we've got ASP.NET Core. So that'll be the other service picking it up. We've got some SQL happening. And yeah, we've even got SQL, and we can start seeing the request and stuff in a second. Well, start seeing the statements that are executing. You read this top to bottom, left to right. So obviously, thing in the very left-hand corner is the first thing that happens first, and it just goes across as a timeline. Anything that's underneath something was triggered by the parent on top, if you like. Does that make sense? Cool. Sweet. So it's not just like, if I have a look at that, I can obviously see where things are taking the time. So I've at least got that SQL execution happening there that's taking quite a bit of time. And over that green block, taking another 119 milliseconds. So, working out where I might start addressing performance, I can easily do from this sort of stuff. But again, not just performance. If I've got an error, and it happens to be across, this transaction touches many systems, working out where that is when I just get a 500 out of the end, out of the API response, can be quite difficult. So here you can see, hey, this thing failed, but this, go and have a look at that. That is exactly what failed. And I don't have to, if you've got a stack trace, it can be quite easy. But if you haven't, you've just got the 500. It can be rather difficult. I've also got the metrics on the side as well. And this is what I was talking about before, where it's not just the trace, you can get some insight to say, hey, 30% of the time is against this database here. And then 16% of the time is within that API. So I can start to address, and see what are the bottlenecks as part of this transaction. Cool. And then just to really drive home the anatomy of this, I guess, this entire thing, all of these blocks together, that's the trace. And then any single block, that's a span. Now, it's not just, hey, I'm going to get like a block within a trace that's displayed on a page. If I clicked onto that in my web browser, within Datadog this is, or within whatever observability system you're using, you would get tons more information. You'd be able to see exactly what the HTTP status was, what the query params were, what service it hit, what region it was running in, all of that sort of stuff. Cool. Yeah, and the other thing to reinforce here as well, I'm going to use the word span and activity quite interchangeably because Microsoft, being Microsoft, are using the word span and activity quite interchangeably. Cool, so that was a bit about Datadog and the screenshots and distributed tracing. Where does OpenTelemetry actually fit into that? So OpenTelemetry is the set of tooling, SDKs, APIs, and standards that basically makes all of this possible within your services. It's basically a standard, but it's a standard that comes with code. It has implementations, and it has implementations in many different frameworks, languages. So it's not just .NET, it's Python, it's Go, it's Rust, it's all of that, right? C++ as well. And the standard defines things like the data format. What does a trace look like? What properties should each of the spans have? The semantic conventions. I don't know about you guys, but when you're trying to query logs and someone has called the service, and then another team has gone, hey, I'm going to call it service.name, and you just can't find the logs for that entire thing. So annoying. So OpenTelemetry has decided they're going to put a stop to that, and we're just going to call service. We're going to call region, region, and we're just going to define what the standards are for that sort of stuff. And also, it covers, how does the trace, if we go back to this, I've got multiple services in this trace. So I start off in my public API, somewhere, ASP.NET Core server, that's another API. How is it that those services share context? That's all governed by the standard. And then finally, there's also the wire protocol as well, the actual format for exporting this information from a service to whatever backend you want to send it to. So it's not like, this only works with Datadog and you've got to go spend an absolute ton on Datadog. You can now use Elasticsearch, which is free, or Jaeger, which we'll have a look at in a minute as well. Any questions or anything on that so far? Cool. Let's not spill that. Awesome. So what does this actually look like? How does it work in production? These guys draw a hell of a lot better than I do. So we'll steal their diagram. But essentially, you instrument your code using the OpenTelemetry SDKs, APIs, exporters. They come in the form of NuGet packages for .NET. And there's also some instrumentation packages as well. So if you do HTTP client stuff, if you do SQL client stuff, you do ASP.NET stuff, you'd go and just go to NuGet and go, hey, give me the NuGet package for OpenTelemetry, SQL client, OpenTelemetry, HTTP client. You then configure essentially a pipeline within your code that says, this is the instrumentation I want, this is all the processing I want to do to it within my service, and then this is where I want to send it to. Now, usually we'll send it to the OpenTelemetry collector, and again, that's another service that's provided by OpenTelemetry. You can run this on a host, just on the same machine as the service. So if you're running in Azure or something, we run it as a container in a mini Kubernetes cluster. So it can either be standalone as like a service, or just like as an agent running on the same host. And then from there, it can be processed, metrics and things can be generated from it, and then it can be exported to a wide variety of backends. So we'll have a look in a minute, but we export it to Prometheus and Jaeger. And Jaeger is a bit like Datadog, a bit like Elasticsearch, Kibana, that sort of stuff. You just get to visualize traces, logs, and that. Cool. And yeah, that's where OpenTelemetry takes care of all of that for us. We're going to skip over that diagram because it's terrible, and we'll write some code. Makes sense to everyone? Happy? Sweet. Okay, cool. So, I thought I opened this. Give Visual Studio a second. Nice. Okay, so we're going to imagine, what are you doing? That we're a startup, and crypto and everything has gone now, that fad has passed, the world is back to normal, and for some reason, the weather is where it's at. Nothing at all to do with the fact that Microsoft Template comes with a weather API, we'll ignore that. But we are a startup that provides weather forecasts for people. And so, we have some code. We have 3 services. We've got a weather API, we've got a forecast service, and we've got an authentication service. I'll give you a quick tour of what we've got at the moment, and give you a quick demo as well, just after. If I go into the weather API, which is my front end, go into the controller, it's rather simple. I've basically got an authentication client that goes and authenticates the user against the authentication service. I've then got a forecast client that takes that user, goes and gets a weather forecast for that user. If I have a look at the client, just to show you it really is quite boring. Oh yeah, I forgot to ask if anyone could see that. Can everyone see that? Better?
Works for me.
Sweet. Just shout out if you can't, I'll zoom in more. Cool, so yeah, quite boring. We just get a HTTP request, add some headers to it, execute it, check it's successful, and then read the response, basically, deserialize. And so if we go to our authentication service, and I can promise you I do not write code like this in production, but for a demo, this is fine. We grab the auth header, check that it starts with basic, and we just grab out, decode that from base64, grab the username, grab the password, and then pass that to our class that hashes our password and then checks if there's a user with that username and password in the database. Again, I don't write code like this normally. Cool. So we return that response once we've got it as a sign-in result. Are they authenticated? Whereabouts are they? Where do we need to provide a forecast for? That sort of stuff. What's their username? And we pass that to our forecast service. Not that. That. Cool. Some of you may know this code. Well, cool. Get forecast for user, just takes the user, and then returns a weather forecast. And like good developers, we've already instrumented a couple of our services with OpenTelemetry. So let's have a look at what that actually looks like. Go and see that. Sweet. Just use PowerShell to send the requests once it loads up. It's not usually this slow. Okay, nice. So we'll send our weather forecast with our basic auth header, and then we can see that today it is 0 degrees, and it's going to be mild. Yeah, kind of accurate. Cool, and then if I refresh Jaeger, which is this, again, this is a bit like Datadog, a bit like Elasticsearch, Kibana, if you've used those tools before, App Insights, just literally an open source tool for viewing traces. And I'm running everything here in memory. If you wanted to deploy Jaeger, you'd have to use Elasticsearch as a backend, or I think it's Cassandra? Yeah, Cassandra. And in which case, you might as well just use Elasticsearch and use their APM, because it's a lot less setup. Sweet. So this is our trace for that request that we just executed. And you can see right at the top, we've got our span for our entire request, hitting the weather API. Next, we hit the authentication service. That's the service we haven't authenticated yet, instrumented. And then once we've got that, we hit our our forecast service. There we go. And we can see that just return a response. That doesn't really do anything. It's the authentication service that seems to be taking the most amount of time, and that's probably where I'm interested as a developer, looking, finding out what's it actually doing? Why is it taking so long? So let's go and have a look at the instrumentation. So if I go into our authentication service, I'll go into our program.cs, our startup class. And I'm just going to add the most simple instrumentation that we possibly can. So it's a it's an ASP.NET Core service. So I'll add some ASP.NET Core telemetry. And so I'll show you where this comes from in a second. I've got this nice extension, add OpenTelemetry tracing, and that comes from, if I look at my NuGet packages, this one here, OpenTelemetry.extensions.hosting. There's a few other NuGet packages that we've got, so we add, because we care about HTTP requests, we care about SQL, as you'll see in a minute, and we're also an ASP.NET Core service. We care about these packages, so we add those. This is where I said earlier, these are release candidates. They are actually stable now. I just put this demo together a while back, and upgrading them on the day that you're doing a demo never is a good idea. So we'll keep them as they are. And then exporters. So it's kind of very plug-in. If I want to export it to Elasticsearch, there's a NuGet package for that. If I want to export it to the console, there's a NuGet package for that. And we'll see how we configure these in a minute. And again, the OpenTelemetry protocol. So this is the wire format that the OpenTelemetry standard provides. And basically, there's quite a few services now that can read that. So Elasticsearch can, using their APM service. If you want to send it to Datadog, you have to send it through the OpenTelemetry collector. And obviously, that being from OpenTelemetry, that can read it. We'll look at that in a second. Does this make sense to everyone? Cool. Sweet. So yeah, back in here, I've got my nice add OpenTelemetry tracing, and I'm just going to configure a very simple instrumentation setup. So I'll go add ASP.NET Core instrumentation and export it to the console. I'm also going to rename that because I have code in a minute. And we will run that. And we'll basically see in a minute that in the console, I get out the activity that's generated and exported. And I'll show you a bit later how that's automatically created and picks up all of the trace context and everything from the parent service. Cool, so back in Jaeger. hit our endpoint again, and now this time we'll go back to Visual Studio, go back to our containers, authentication service, logs. Oh, I forgot to clear it. That's fine. This here, this is our activity. So what does it contain? Well, first off, it contains an ID. This trace ID is unique to the entire transaction. So every service that it hits, it's the same for, basically. We then have a span ID. And if I come back to this, so essentially, trace ID is unique to this entire thing. Span ID is unique to each one of those little spans, those little blocks, if that makes sense. Cool. And then we've got some other information. So you might want to do sampling if you've got a really high traffic environment. And so there's flags for that, if it's recorded, if it's not. Do I need to care listening for it if it's not, that sort of thing. And then there's an activity source name. So what generated this instrumentation? It was ASP.NET Core. A display name for how you want to display it. So for ASP.NET, it's usually the endpoint that you're hitting. You probably want to configure that. So if you've got parameters, it displays the root rather than the actual parameter, because otherwise you'll get a whole bunch of endpoints in your traces. Cool. And if it's SQL, it's quite handy, as we'll see in a minute, to actually show the statement that's being executed. And then we've got some other stuff like when did it start, how long did it take, and some tags. These are entirely up to you what you add. For stuff that comes out of the box, like ASP.NET Core, SQL, there's a whole bunch of defaults. You can add extra. Awesome. And then we'll have a look at this in a minute. Service name, unknown service.net. This is kind of one of the things that could be 10 times better. The development experience isn't great. There's a lot to set up to get started with. Once you've got it set up, though, it's just rock solid and it works. It's just getting it set up and tuned to exactly how you want it. And there's a lot of defaults that they probably could adopt that would make that a lot easier. So any questions on that first, I guess? No? Sweet. Cool. So instead of sending it to the console, let's actually export it to Jaeger. And so we can do that just by calling that one, add OTLP exporter. And here we just say, set the endpoint, new URI. I'm running everything in Docker, so I just call it the container name, which is collector. And by default, it runs on port 4317. We'll have a look at that in a minute. Ah, no. Semicolon. Awesome. And then just to show you how the collector works, the collector is just a Docker image that you can grab from Docker Hub. In the OTel repository, OpenTelemetry collector contrib, just minimize that. And it just has a simple config file, and you basically declare a pipeline. So you say, hey, I received data on the OTLP protocol, either using gRPC or HTTP. You can configure the ports here. The default for gRPC, 4317, 4318 for HTTP. I can process it. So I can batch all of my spans together for a time period rather than creating like a HTTP request to my backend and sending one at a time. I can batch that. In prod, we set that to 10 seconds, so just 10 seconds worth of data in one single request to the backend. I can generate some metrics from it. We'll look at that in a minute. And then here I can define where I'm exporting that data. So loads of different exporters in the contrib image. For this one, we're just using Jaeger, and we're setting the endpoint to our Jaeger endpoint. Cool. I tie that all together in a pipeline to say, hey, for traces, receive it on that OTLP, do this processing to it, and then export it to Jaeger. And that's just some console logging there. Awesome. And then I think Jaeger actually loaded up. It did, so let's send another request. Cool. Give it a second. Find traces. Cool. So yeah, now I've got my trace in Jaeger, much more accessible to my developers. And I can see now that that weather API is making the request to the authentication service. We still need to go and fix that. But yeah, the interesting question here is, why is this taking so long? All it's doing is hashing a password and getting some data out of database, right? It should be quick. Cool. So let's go and fix this first. And I'm just going to pinch some code because you don't want to see me type all this. If I go to my program file again, and I'll talk through this. So essentially, the tracer builder has the concept of a resource, and a resource in OpenTelemetry is the thing that produces telemetry, so the service in this case. And so we create a resource builder, and we say, add this service, and we just add all of the details about the service. So we say, here is the name, default it to the assembly name, you can customize that, set it to whatever you want. We can give it a namespace. So a lot of companies have services that are, or there's a family of services that equal, like, I don't know, a business product, if you like. So in here, we can give it that namespace, and that makes it a little bit easier to see all of that telemetry in your backend. It's really up to your backend, Jaeger, Datadog, Elastic, what it does with that. The version of the assembly, this, like, adding the version to your telemetry is one of the easiest things you can do, but with just such huge, like, payback. Seeing in graphs that, like, I deployed here, and before that it was perfectly fine, and it's a new version, and now I've got like thousands of errors. Knowing that is fantastic. It just makes your life so much more easier. And then usually, you have multiple instances of a service running. So if you're on-prem, you might want to know, hey, which host is actually running this in the cloud. You're probably going to get a nonsense name there. But knowing that it's this particular instance, again, useful. Cool. And then we can add our own tags and stuff to this. So the OpenTelemetry standard provides some additional things. So we can say deployment.environment, production, staging, integration, UAT, whatever environment it is. Also free-for-all as well. So you can go and add your own. And these attributes here will be added to all of the spans that you produce. So something that we do at Codat is we add an owning team tag. And that's really useful for if you're creating like a standard alert to say, hey, none of the service error rates should be over, like, I don't know, 3%, 5%, 1%, whatever. I can use this tag to then alert the correct Slack channel, because it should be team name -alerts based on our conventions. And Datadog lets you do that. So yeah, so custom there. And then we just finally finish it all off and say, hey, set the resource builder on this builder to resource builder. And so if I run that again, this time I'll see all of that information added to all of my spans. Does that make sense? Cool. Sweet. Grab that again. Cool. So yeah, run that. Give it a second. There we go. And so we can see now, rather than unnamed service, we quite handily get authentication service. If I click on that, click on the process, I can see, hey, this is production. The SRE team owns it, which is really useful again. Alerts, and also if you've got a massive transaction that crosses multiple service boundaries and multiple people own those services, knowing that this thing is failing, that team owns it, go and speak to them. Quite useful. This is the version as well. Again, there's a load of things you can add in here. Region, if you've got multiple instances in multiple regions, you can add that. Cool, so that's that. Again, we want to know why this is taking so long. So as any reasonable developer, it's probably not our code, and it's probably the database or the network that's causing this issue, right? So let's go and add some database instrumentation, see how long the database is taking. And that's quite simple. So all I need to do here is go, hey, builder, give me some SQL client instrumentation. And let's run that. So rather than going in and wrapping each SQL request, each SQL statement, I should say, in a log statement, say, hey, this is how long it took, this is what I executed, this is what the parameters were, it can just pick this up automatically for me. So I think that's loaded. It has. Let's run it again, find a trace, give it a second to come through. There we go. Awesome. So now we can see our authentication service, and we can see, hey, the DBA has basically come back to you and told you that it isn't the database, it's your code, go and look harder. And so yeah, only, 34 milliseconds out of a total of 541, so it's not that. But there's some things that would make this a lot easier. I don't know about you, but my code usually contains, our services usually contain a lot of SQL queries. And so knowing, it's query A from query B is quite useful as well. So being able to see that and set that display name rather than just seeing, hey, it's a database call, again, quite useful. And I can do that here. Now, most of these instrumentation packages give you 2 extension points. They give you, one, the ability to filter stuff out. So for ASP.NET Core instrumentation, I can just go x.filter. That gives me a predicate to decide, do I care about this thing or not? So if it's, a health check coming from my load balancer, I can probably safely ignore that. I don't want to pay for the storage fees for the traces. Also, they give you the ability to enrich the spans that it produces. So if you don't like the defaults, you can go and add extra. Again, I'm going to steal some code. We will steal that. Talk through it. So yeah, there's our enrich delegate. And basically it passes us 3 things. It passes us the activity. Again, going back to our first thing, activity equals span, used interchangeably. I'll explain why in a minute. The name of the activity, and also an object. So for a HTTP request, they'll pass you either the HTTP request or the response object. You get this called twice on the way in and the way out. For SQL, we can get the actual command. So what we can do here is cast that command object to an IDB command, and we can set the display name to the command text, and we can grab some more information as well. So peer.service is a standard attribute for if you're calling a remote service, this is the name that I want to give it. So in this case, give it the database name. HTTP, I'll give it the name of the service that I'm calling. So let's rerun that. Grab that. Too fast. Does this make sense and everything to everyone? Questions? Cool. Awesome. So if I find traces again. Nice. So yeah, now I click on that and I can see exactly, what that statement was. And this comes in super, super useful when you've got, a service that creates thousands of SQL queries. And just to show you how that might look in a different system or a live system, this is one of our databases in Datadog using this data. And basically we can see for all of from an application perspective, for all of the queries that it executes, which one has the most requests, which one is taking the longest, all of that sort of stuff. So I can just go straight in, drill into it, find out what's taken an age. And so I don't have to go and ask my DBA. If the database is slow, I can go and work that out for myself. And yeah, this isn't trace data. This is trace data, but it's metrics from that trace data that Datadog automatically for us just generates. But you can do exactly the same thing if you don't use Datadog using this span metrics processor. And so that will pull off usually your red metrics, requests, errors, durations, latency buckets, all of that sort of stuff. And you can add any dimensions you want to that. So for HTTP, I've got the method, the status code, the service. So, knowing that 500s or requests that result in a 500 status code, are they failing fast? Are they failing slow? Again, super useful. Cool. So that's our SQL request. And so, if I go back to it, yeah. So our DBA has already told us that it's not the database that's causing the issue. What else is it? So we need to go and have a look actually at our code and see what could be causing the problem. So let's go and do that. In our authentication service. So really, I only do two things. I hash a password and I query the database to see if that user and password actually exists, right? And so it could be this. It probably is this, considering that's the only other thing we do. Now, this isn't something being called externally. So, the OpenTelemetry package, there isn't going to be an instrumentation package that says, hey, this is the one to plug in if you're hashing a password. You've got to instrument that yourself. How does that work? Terrible diagram time, and I do apologize straight away. But how does it work under the hood? I guess is what we need to know before we start looking at this. So we've already seen that within a service, we need to reference our OpenTelemetry packages, we need to reference the instrumentation, the exporter, and the SDK package that gives us the tracer provider builder, which we've been configuring in the program file. But we also get from .NET, and this is where .NET really differs from like Python or Go, because in Python and Go, OpenTelemetry provides, hey, this is the thing that's a span. In .NET, we already had things like the ETW events, diagnostic event source, all of that stuff. And when this came out, the guys at Microsoft were like, hey, we should probably use that because that's what everyone's using already. And so we use system.diagnostics.activity to represent a span. And so the way we listen to that and hook into it is there's an activity listener that tracer provider creates for us, and all of those instrumentation packages say, hey, you the listener, you should listen to this type of span. And we'll see exactly how that works in a second. And basically I suppose it's tied together by strings as essentially you have an activity source that creates an activity, and the activity listener decides whether or not it should listen to it based on whether it has that activity source's name registered or not. So to show how that works in code, the first thing we need is an activity source. So we can go var fact using, no, just var source equals so we can new that up. We give it a name. So we'll go dotnetsheff. And then we'll say using var activity. So this is our span here. And the reason I'm using is because activity is idisposable. And basically the point at which you dispose it is the point at which it knows, hey, this span is complete. So we go using that equals source.start activity. We'll give it a name. Might as well give it the name of the method. Cool. And then if we register this, so it's called dotnetsheff. If I go to my program.cs file, and I can register my own custom instrumentation just using builder.addSource. Nice. And so if I run that now, give it a second. Oh, too fast. There we go. Cool. Find my traces. That's the one that errored. Awesome. Oh, I love it. Usually this comes out as a really nice long span, so you can see exactly that it was the hash password, but demos being demos, we'll imagine that's a little bit longer. Essentially, you can see now we've got our custom hash password instrumentation, so that's exactly how long that hash password function actually took. Cool. Any questions or anything on that bit? No, sweet. And so one of the things that you probably don't want to do is go around your code and just start littering it with, hey, var source equals this, and then you have 1,000,001 different things that you register in here. And so one of the ways we've kind of worked around this, or improved it, is we register at Codat a activity source provider, which is basically just a wrapper for an activity source. And then we can add that to our dependency injection container, just inject that whenever we need it, and go, hey, activity source provider.current.start. Cool, so that's that. We've looked at some performance things. What about errors? How do they look when things fail? Oh no, I meant to throw an error. And so let's say that we've got a support request. Cool. Yeah, let's say we've got a support call. No idea why, but this seems to be failing. You can obviously spot what the issue is, but just for a demo, yeah, we run that. Our customers are getting back this, well, if we've not configured our service correctly, this big exception. And so what does that look like here? So we can see that, we tried to execute the weather API endpoint. We made our HTTP request to our authentication service, and then our authentication service had an error. If I go into the tags, I can see what the error was. But I don't know about you, that's when I'm looking at an exception, I want a stack trace so I can actually go and figure out that, hey, it was this line of code that caused the problem, rather than just a message that could happen in probably multiple places, right? And this is, again, one of those things where developer experience could be 10 times better. Just enable this by default, everyone's happy. Cool. And so if I go into the program.cs file, there's a property on here called record exception. If we set that to true and run that, and then execute our HTTP request again once it loads. You there? Yeah, sweet. Cool. So there's that. I can go in here, I can click back into that. We get this logs thing. Let's click in there. And there we go. There's exactly, what our exception was. This is the line of code you need to go and have a look at from the stack trace. Cool. So that's that. Now, again, how does this actually hang together? So when I, send a proper request that actually succeeds, how is it that if I've got many requests happening at the same time, then it knows that this particular invocation of that endpoint matches up with this particular invocation of that other endpoint on that other service. And especially if things aren't different languages and stuff, how does that all work? How does that happen automatically for us? Well, if I set some breakpoints, we can actually have a look. So let's set one at the entry point in the weather API. We'll just pop one there, and we'll set one as well in our authentication service. So go in our controller, and we'll just set it right at the start. Execute a request. Sweet. So we come in here, and because this service is already instrumented in exactly the same way, it's just got go and add me the, where am I? I'm there. Go and add OpenTelemetry tracing, go and add the attributes, go and add ASP.NET Core, all of that stuff, exactly the same. then what happens is when a request comes in to the ASP.NET Core server, there's essentially like a bit of middleware that will go and create an activity for you. And so if I have a look at the best way to do this, can we see that? Probably not. If only there was a way to zoom in. Windows what, sorry? Windows key and plus. Where's my watch gone? Let's not do that. A little bit too much. Okay, that'll do for now. Perfect. How do I get it to move around? Oh, sweet. You learn something new every day. Okay, cool. So here's our activity, and you can just access it. It's a static async local, so that's how it flows across async boundaries. And we can see here is our, where's our trace ID? There's our trace ID that's generated automatically for us. And we've got all the other information as well. So we've got our span ID. It's already added automatically what the endpoints and everything were. But if we just remember that starts with DEB, and then let me try and get out of this. In fact, let's not. Let's F5, edit. Sweet. Cool, so now I'm in my other service. I'm in my authentication service. And if we do the same thing again, cool, we can see here, our trace ID is exactly the same. How does that cross boundaries? And so it's actually quite simple. The Microsoft have basically gone all in on this and instrumented all of their libraries. So the HTTP client library knows that if that property, system.diagnostics.activity.current, isn't null, there's something there, propagate automatically the trace ID and the trace context in the headers. So if I have a look down here, we can see here there's a trace parent header, and it automatically contains, it's basically a WC3 ID. So what version of the standard it is, the trace ID, and the parent span ID, so that's how the child-parent relationship and everything works, and then some additional flags, am I sampled or not, that sort of thing. Cool, and that doesn't just work across HTTP boundaries as well. So things like if you use Azure, if you use Service Bus, then again, if system diagnostics activity current is set to something other than null, the SDK for Service Bus knows, hey, I'm going to add that diagnostic header as a diagnostic ID on the message header for you. And then the SDK again knows that, if that header exists, I'll create an activity automatically for you in the service, or in the consuming service. Does that make sense? Sweet. And so, one more thing to have a look at is I said right at the start that if you have a look at these things, you click into them, you'll get a load of information. We've already seen that, but you can customize what information is on them as well. We can absolutely do that. So let's imagine that, let's get rid of that. We care about where our particular users are, right? Because maybe there's additional latency or something. So we want to see that telemetry sliced and diced by user location. That user location for us is just coming from the database where they've said their country is. We could also do like reverse GeoIP lookups, all of that sort of crazy stuff. I'm not going to do that here. But let's see how we can add that information actually to the data. So if I go to my forecast controller, at this point, I've got the user, so I know what it is. I can just access activity, if I can spell, in the system diagnostics namespace, .current, and then just set additional data. So I've got here, add tag, and that just literally adds a tag, as you've already seen it in Jaeger, where you can see, like HTTP host was this server name. So we'll add one here called country, and we'll set that to user.country. Now what I can also do, and that we found quite useful at Codat, is I can propagate this information to other services as well. So I can do activity.current.add baggage. And basically what this does is when this is set to something, HTTP library again knows, hey, you've got some information there, I'll propagate it across in the request headers for you. Now what isn't as nice here is that you have to manually then go and, if you want to display that in the tags of the downstream service, you've got to go and pick that off. So we'll have a look at what this looks like. Too eager. Get rid of the breakpoints. Sweet. And then back in here, if I then have a look at, give me this one. Did I not add that? I thought I did. There was, there we go, tags country. I was looking at the wrong thing. And so yeah, I can see that information. And then if I want to use that as a metric for, something like this, maybe that's a parameter, I can then start, adding that, building that into my telemetry system to actually use that, add it as a dimension. Cool. That's pretty much OpenTelemetry in a nutshell. Thank you, and any questions or anything?